talk about streaming integration, what it is, a little bit about what it's used for, and most importantly, the components that go into being able to do streaming integration. So you, like all enterprises, have a lot of data sources. These data sources are continually producing data. They could be databases, machine logs, or other files that are being produced in your systems. They could be messaging systems. They could be sensors or IoT data. And it's being generated all of the time. But it's not in the form or the place or the technology that you want it to be in order to be able to get value out of it, to be able to make decisions on it. So you want to move it to other places. Maybe you want to put it into cloud storage or other types of storage. Maybe you want to put it into different databases or different data warehouses. Maybe you want to put it onto messaging systems so that you can build applications, analytics, reporting, so that analysts, data scientists, decision makers, and your customers can get value out of it. So streaming integration is about being able to collect the data in real time from the systems that are generating it and to put it into the place that it needs to be so you can get value out of it. So what are the components of streaming integration? Well, firstly, we start with being able to collect data. So continuous data collection, being able to get to the data in real time. Now that isn't as easy as it sounds because every different place that data can be requires a different way of getting to the data. For example, databases. Most people think of databases as a historical record of what's happened in the past. So you can query databases, you can run queries against them and get bulk results out. But in order to do real-time data, to get the data as it's being generated, you need a technology called change data capture, or CDC. And that is going to be able to get you the inserts, updates and deletes that are happening in the database in real time as they're being generated. Similarly for other sources of data, for files, for messaging systems, you need specific technologies. You need APIs that work with those systems. For files, you need to be able to tail the file, read at the end of the file, maybe multiple files across multiple systems in parallel, and stream all of those in. So you need specific technologies in order to be able to get to the data that you want. Once you've got that data, you need to be able to put it somewhere else. So you need to be able to deliver that data to the target systems. Now that data delivery kind of really depends, again, on the type of target system. And because you are doing database change and change collection on the source side, when you deliver things into your target systems, the delivery process also needs to be change aware. So you do the right thing with an insert or an update or a delete. For example, if you are synchronizing an on-premise database with a cloud database, then you need to initially load the data, but you also need to apply change to it. And so the delivery process needs to be able to understand that instead of just inserting all of these events that I'm getting on a streaming platform into the database, I need to treat an insert as an insert, an update as an update, a delete as a delete. And that's in a heterogeneous fashion. So if you're taking stuff from an on-premise database and putting it into a cloud data warehouse, for example, that should work too. You also need to be able to work with lots of different APIs again, like you need to be able to work with databases, with storage, with messaging, and you also need to be able to support different cloud systems. So for example, the security mechanisms that are used around the different cloud vendors are all different. So you need to be able to do that as well. So streaming integration needs to be able to collect data and it needs to be able to deliver data. In between that, obviously, it needs to be able to move the data. So continuously move the data that's being collected into the appropriate target. And potentially to do that in a fan-in, fan-out way. So take multiple sources, combine them together and push them out to a single target. Or take data from a single source and move it and deliver it continuously to multiple targets. So this data movement has to be smart. It has to be able to move data between processes, between nodes in a clustered environment, to be able to move data from on-premise to cloud or cloud to on-premise or across different networks, maybe across different clouds. And this data movement has to be really high speed and low latency. So you need to be able to deliver the data from one place to another really quickly. Typically though, in a lot of use cases, you're not just dealing with the raw data. If you're doing a database replication, then yes, you can collect change on one side and apply that change exactly as is to the target. But in a lot of cases, you want to manipulate the data in some way. The format of the data, the structure of it, the content of it that you collect may not be enough, may not be correct, may not be sufficient for where you want to put it. So you may need to do some kind of stream processing. So this is about being able to take the data that's on the data stream and manipulate it. You may want to filter it. Maybe everything you collect doesn't need to be written to everything you deliver to. Maybe only a subset is written to storage. Maybe only a subset goes into messaging. So you need to be able to filter that data and choose what goes where. You also need to be able to transform it, to give it the structure that you want, to apply functions to it in order to make it look like you need. In these days, maybe you also need to be able to worry about security. Maybe you need to mask some of the data, obfuscate it in some way. If you're doing cloud analytics and you have personally identifiable information coming from your sources, then it's probably a good idea to anonymize that data before you put it into the cloud for analytics. So being able to do that as it streams through is really important. Maybe you need to be able to encrypt the data. Combine data together, take data from multiple sources and combine it through some mechanism, through some identifier into a single data stream that you then apply into a target. Maybe you need to kind of aggregate or summarize the data before you write it into a data warehouse. Or maybe it doesn't contain enough information by itself. Maybe you need to denormalize it or enrich it before it is delivered somewhere else. So for streaming integration platforms, you need to be able to do all of these different types of processing on the data in order to get it in the form that you want before you deliver it. You also need to be able to get insights on the data. So to be able to see how the data is flowing, whether there are any issues in the data flow, maybe even investigate the data itself if there are any issues. And this can be ad hoc, you could be going in and just looking at it, but from an operational perspective, it's also important that you can get alerts if anything is failing, or maybe get alerts if there is an unusual volume of data coming from one particular place. Maybe suddenly there's an unusual volume coming from your order table, or maybe there isn't sufficient volume. Maybe it's fallen behind what you'd expect for that time of day. So being able to get alerts on the data flows themselves can be really, really important. And finally, for streaming integration, you can play about with streaming integration components in the lab. But if you're going to put things into production, streaming integration needs to be enterprise grade. Everything needs to be able to scale. Typically, you're talking about large volumes of data being generated continuously for streaming integration. And so you need to be able to deal with scalability. And maybe you're adding additional scale over time. So you're probably looking at a clustered, distributed environment where you can add new nodes into that environment as you need to in order to be able to handle scale. And of course, for mission-critical platforms, for mission-critical data flows, it needs to be reliable. You need to be able to say, if I collect data, if data is generated on this source side, then I have to be able to guarantee that it makes it into my targets. So to be able to say, if I am replicating a database that's on-premise into a data warehouse that's in the cloud, I need to make sure that every single operation makes it from one end to the other, and that I can investigate that and validate that that has actually happened. So for streaming integration to be enterprise grade and work with mission critical applications, you need to be able to ensure that it is reliable. And that at minimum should be at least once processing, that everything that's generated on the source makes it to the target. In certain cases, you need exactly once processing. Not only does it make it to the target, but you guarantee that even in the cases of failure, it only ever makes it to the target once. So reliability is also really important. And of course, security is important. We've talked about data security by being able to mask and encrypt data as it flows. Of course, data movement, as things are moving across networks, all of that data should be encrypted so that people can't tap into the network flow. But also from a security perspective, you need to be able to lock down who has access to what in the system that is doing all of these things. If you're generating a data stream on-premise and it has personally identifiable information in it, you need to be able to lock down which employees can access that data stream, even through the streaming platform. And so being able to do authentication and authorization within the streaming platform itself is also essential. So in summary, streaming integration is about continually collecting data from enterprise and cloud sources, being able to process that data while it's moving, deliver it into any target that you want, whether it's on-premise or cloud, being able to get insights into how it's moving, and do all of this in an enterprise-grade way that is scalable, reliable, and secure.